Well, that's 20 minutes of video you didn't need to bother watching because I was recording to a Duff memory card. So we've got a Fidelity 1000 here and it's got no transmit. So what I was saying to myself was we've got transmit coming out of the set. I'll just put the power back on. Our hand portable, it is transmitting. So it's nothing coming out of the transmitter. So we've got it in the phase lock loop stage. That needs, when we've put this together, that needs a bit of soldering up over the microphonic. The tune-up starts on transmit at that coil, then moves on to this circuit diagram which we've dug out, and what I was just doing is looking around L4 and L5 as to where the signal is disappearing. And we seem to have got a problem there. If I'm not barking up the wrong tree, out of L6 should be going into L7. Yes. So what I was going to do is to take this transistor out here, and that is transistor number Q17, which is there on the circuit. Right, having got the transistor out, it was in a funny way around, but that might be the way it has to be. The board is marked. It's an ED1502. Which we probably have new in stock. But we'll test this one. No, doesn't work, does it? No, Mr. Tango, it doesn't. Next question is, have we got a scrap set? My problem is I keep rebuilding them all. I'll tell you what, we'll see if we've got a new part. Right, so I've had to find a scrap set. I didn't see new ones in stock. Oh, this one's still got a meter. I'll bear that in mind. So it's come out a very funny way, just like the printed circuit board was designed for a different device. Protection between something or other. That doesn't sound right. I really need to look at this pinout more closely. I think we've got blue emitter, green collector. Blue is base, green is collector, red is emitter. So it needs to go in. Needs to go in that way round. It's an absolute pain when you having to put transistors in funny ways round. Right, so I've put the transistor in now, and I've just flicked up the transmitter, and we have transmit. Way! And that's full scale deflection of 3 watts. So we'll start our filling in the form now. And of course all the test gear's now been on for more than an hour. Good. First part suspected was the fault. So could well have been a bad SWR. Right, picture in picture, is it on? Yes it is. And we can just start writing down these parameters. So it's 3 watts on exactly for 20. So remember, these are a 3.5 watt set, they're not a 4 watt set. The odd one will do 4 watts. I'll say that again, the odd one will do 4 watts, but some will do as little as 1.7. And they're still not faulty. 2.8. And channel 1, we've got really good audio, 3.1. And remember, this is a commercial test set, and if I say something's 4 watts on here, then it could well read 7 on a amateur spec meter. But you know, the government used this kind of laboratory thing, and so it's this that counts. Right, low power. It's not adjustable on these, and it's 210 milliwatt. And our current consumption is very good, 694 milliamps, which is incredibly efficient. Deviation, see if the meter's working today. Wallow, if it is, it's 3.1, which is too high. We won't be doing the VCO. The frequency, go to the frequency meter. 27, we're still on channel 1. That made the other one test invalid. Wallow, it's 3.9 kilohertz. Nothing like transmitting on several channels at once. And then back to this, 2779097. So it's 2779097. So I'm going to pull that up right now, and then we won't have to fiddle about with compensating the signal generator. So take this off. Easier said than done. Do not disturb these ribbon cables. They're as weak as dishwater. Trim a capacitor down there, don't disturb any of the others. Very good quality trimmer capacitor, far better than in most sets, and yet these are a cheap set. Well, it looks like it's going the full way. 40 years old and crystal's still within spec. Put that lid back on. Shouldn't have to go in there again because we know the set's receiving. Looks like the crystal's uniden. Does that mean somebody's changed it? Check the set still works. Yep. And this is the important thing to solder up to stop it rattling around and causing microphony. Right, here goes the tune-up. So we're in transmit, we're on channel 20, it's doing 3 watts. That's in the centre. That's now in the centre. That was correct. That was correct. So we're now at 3.4 watts. That was correct. I'm having difficulty moving that. I don't want to break the plastic trim tool, so chances are I'll go and fetch an Allen key, not to adjust it using an Allen key, don't get me wrong on that, but to just be able to move it. So we'll come back to that. So we're now at 3.4 watts. That may be all it doesn't matter. It's plumbing site more than a lot of new sets do. So we'll look at the deviation, because I can do that. I'm going to plug into the test set behind. No, I'll tell you what we'll do. We'll do the deviation first on here, and then we'll go on to the other test set to see whether it's still correct. Wallow. So just verify it with the test set behind me, just in case this one's playing up today on deviation. One spot on. As I've said before, it clearly needs capacitors in the power supply. Oh, but it's not getting them. With 3 of these test sets, it's only one we do the CBs on here, but there we are. Right, so that's deviation done. So 2.2 to 2.5 kilohertz, 27,79125. The meter lamp is lit. We should have taken the meter reading. We haven't finished doing the transmitter. It actually reads 3.5, which is actually what it's doing. So that's correct at the moment. Let's look at the receiver on some test gear. Right, we'll plug in the test instrument. I put the attenuation on this, as I said before, and I need to take it off again because I can hear it, but you can't. And people who moan that it spoils their enjoyment listening to 1 kilohertz tone, well, it's tough because that's the reality of a workshop. Oh, I'm going to have to connect both to this. And I haven't got 2 crocodile clips here. Oh well, just have to hold one on, won't we? Right, so go to the SINAD meter. And 12 dB, 0.41. Ten dB, 0.33, 20 dB if it'll do it. Yes, it will. 0.84. Squelch. Go to the attenuator for that. So full squelch. (280 microvolts). So bring that down a bit. Threshold. .96. S9 is a bit generous. (20 microvolts). Good. Right, let's see whether we can get a bit more out of this receiver. So a very strange setup, as you all know by now. detectors. It's not like a normal set. That's now right. That's that one. Now we'll do the SINAD. Keeping the signal low so we don't saturate the receiver. That was already spot on. That was already spot on. That wanted a little adjustment. That was spot on. One thing, it's not been fiddled with, has it? Let's get a new reading. Won't be much different, but it will be different. So for 12 dB, we've now got 0.48, which is actually worse. And that's because the detector was out. Zero point 0.4 and for 20 this will probably be better. Yeah, 0.82. Squelch. Need to adjust that so that the squelch comes in. Unless of course that's the meter. That's exactly where we want it, 100 microvolts. And let's look at the sensitivity. Zero 0.65. Now that's so much better. Well, we'll just do the S meter. I can't hold these wires and show you all this at the same time, unfortunately. We've now got 100 microvolts for the S meter. Good. Right, we'll go back to the transmitter. I'll have to go and get an Allen key. Okay, so I've freed it off with the Allen key. I've then gone in with the blue tool, and we've now got it to 3.6 watts. Now, is that coil supposed to be like that? The answer is no. I've just looked at the scrap chassis. So we'll just make sure that's in the correct placement position. Could do with some plastic tweezers, but without going into transmit, I'll just close that up, and then we'll just see the effect. So Mr. Coil Stretcher didn't help the set because it's now 3.7 watts. So let's see where it is on the other channels. Channel 1, 3.6 watts. Check that again. Channel 40, 3.6 watts. I've got it absolutely balanced. So 3.6, 3.7, 3.6 watts. It's now, let's go back to channel 20, yes. It's now 844 milliamps. So we've gained 3/4 of a watt, haven't we, effectively on channel 20. Let's see what it is on low power. I'm not even showing you the right meter, am I? Right, low power. That's 400 milliwatts, that's 220 milliwatts, it's gone up a little tiny bit. Back to normal power. Whoops. Yeah, it's 3.8 when it's cold, to be honest. So what does the meter read on the front? It's bang on the 4. So I don't need to change that. It's the adjustment down there. That's the only thing which wasn't out. So it's not being messed with apart from the deviation. So there we are, we're done. Really annoying it doesn't have an extension speaker socket, but it doesn't. And only 1.5 watts of audio output, so not something you could really successfully use in a car. Unless you've got a very quiet car. I wonder where the solder's gone. I think the word is on the floor. On the dog shelf. So one Duff transistor and a retune. Probably told you all before that the squelch on these sets is AM. There's an AM detector specially to do, and only to do, the squelch. So just imagine them at Great Electronics in Taiwan. Years of expertise in building cheap CB radios, but when it came to the squelch, we only know the AM way to do it. I won't put all the screws in for now. Just enough for it to not fall apart. I know what I need to check while it's still on the test gear. The customer's mic. We'll just do the one side. So I want to listen to this on our hand portable. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So we know how that is. And then we've got customer's mic. Testing 1 2 3 1 2 1 2 1 2 1 2. Bit bassier, but it works. Better just check the deviation, do the job properly. Wow. Yeah, that's fine. So our mics are a little bit crispier. You'll find that out on the air test, which will be probably a couple of days. Right, take it off the test gear, switch the test gear off, switch everything off, and we'll go to the roof aerial. No pig farm video today. 19 Roger. So it only reads 3 now, but it doesn't mean the radio's only doing 3, because the meter is relative to SWR. So always bear that in mind. When I do the on the air test, we've got it on our aerial, I've set this meter. We know the radio's doing 3.5 watts. I've set the meter to 4, which is what you do. Well, I know we know the radio's doing 3.7 watts, 3.8 when it's cold. I've set the meter to 4, but when we put it on the aerial, it could bang across, or it could hardly move. But the radio's still doing the same power because that reading is relative to SWR. So don't ever rely on it. Sunday, it's about 1:30. They're probably all having a dinner with their mummy. 19, a quick rig check. Ha, nothing. More sensitive than most sets. There we go. Fidelity 1000, no transmit, sorted out. Thanks for watching.